Hi everybody, Mr. Garrett here again, and we're going to talk about the binomial theorem and the second review problem for tomorrow's group quiz. So I hope this helps. The first question says, use the binomial theorem to expand the binomial 2x minus y cubed raised to the fifth power. We're going to go ahead and do that right down here. And the first thing we're going to do is write out the coefficients from Pascal's triangle for the fifth row. Alright, and so looking at Pascal's triangle, I know it goes 1, 5, 10, 10, 5, 1. And I'm going to put little plus signs in front of the coefficients. We're going to try and write these as best as we can. Alright, the next thing I do is I grab the green marker and I circle the first term, which is 2x. And I'm going to start by saying 2x to the fifth, then 2x to the fourth, and then 2x to the third, and then 2x squared, 2x to the first, and 2x to the 0. So I take that first term, I start with the same exponent that I have right here, and then I work my way down. The second term is negative y cubed. And so I'm going to start here with the first term here and say negative y cubed to the 0, negative y cubed to the first, negative y cubed to the second, negative y cubed to the third, negative y cubed to the fourth, and then negative y cubed to the fifth. Okay? Now, normally I say this next step is an intermediate step, but I would probably make sure that you write this down, even though it's optional. And what I'm going to do is I'm just going to go ahead and work the exponents. So I got 1 as my coefficient, 2x to the fifth is 32x to the fifth, and then negative y cubed to the 0 is also just 1. So that's pretty easy. Okay, so then the next one is 5. 2x to the fourth is 16x to the fourth. And then negative y cubed to the first is negative y cubed. That should be plus there. And then we got plus 10. 2x cubed is 8x cubed. Negative y cubed squared is y to the sixth, positive. And then we got 10, 2x squared is 4x squared. Negative y cubed cubed is negative y to the ninth, power to a power we multiply. The next one is 5. 2x to the first is just 2x. And then negative y cubed to the fourth is going to be negative y, or positive y to the 12th, I'm sorry. And then the last one is 1. 2x to the 0 is also 1, and negative y cubed to the fifth is negative y to the 15th. So that was our intermediate or optional step, and now what we do is we just multiply everything together. 1 times 32x to the fifth is 32x to the fifth. 5 times 16 is 80, and actually I should erase this because there's a negative y cubed there. So what that means is that this is actually going to be negative 80x to the fourth, y to the third. Then we have 10 times 8 times all that, so that's going to be 80x cubed y to the sixth. And then we have negative 40x squared y to the ninth. It's negative because of this negative sign there. And then we have 5 times 2, which is 10, so that's 10x y to the 12th. And then the last one is negative y to the 15th. So there is the final answer. Again, I write down the coefficients, 1, 5, 10, 10, 5, 1. You can see those in black. Then I go to the green, which is the first term, and I raise that to the highest exponent, 5, then 4, then 3, then 2, then 1, then 0. Then I go into blue and I circle the second term and I say negative y cubed to the 0, negative y cubed to the first, negative y cubed squared, third, fourth, and fifth. I simplify everything using the exponents, and in something like this where you have a coefficient of 2 and you have a negative y cubed, it's a wise thing to do. Normally if it's pretty easy you don't have to do that. And then I simplify the remaining result, and that's what I get. Now the next part says use the binomial theorem to give the first 3 terms and the 14th term of a squared plus 3b to the 18th. Now this is a little bit easier. A squared plus 3b to the 18th. Now I know that the first coefficient is going to be 1, and I know that the second coefficient is going to be 18. What I don't know is what this third coefficient is going to be. However, I do know that we get 1 by doing 18 over 0, and we do 18, or get 18 by doing 18 over 1, and so the third one is going to be 18 over 2. And if I plug 18 over 2 in my calculator, I actually get 153. So that's 18 over 2. So that's the third number in the row 18 of Pascal's triangle. The next thing I'm going to do is I'm going to take this first term, which is a squared, and say a squared to the 18th. And then I do a squared to the 17th. And then I do a squared to the 16th. So we start at 18, then go 17, then 16. And then we take the 3b, and we say 3b to the 0, 3b to the 1, and 3b squared. Okay? Next step, I'm going to go ahead and do each part. So that's 1, a to the 36th, and then 3b to the 0 is 1, plus 18, this is a to the 34th, times 3b, and then the last one is 153, a to the 32nd, 9b squared. And then the last step is to multiply everything together, and I get a to the 36th plus 18 times 3 is 54, a to the 34th b, and then 153 a to the 32nd, 153 times, sorry, missed that, 153 times 9, 153 times 9 is 1377, and then a to the 32nd b squared. So those are the first 3 terms of our expanded binomial. Now if I had to write it all out, there'd be 19 total terms. That's a lot of work. Now the second part says what's the 14th term? And to find the 14th term, you have to kind of understand that there's 3 parts. There's the binomial coefficient, there's the first term raised to some power, and then there's the second term raised to some power. And when we do this, I'm going to actually change this back over so it's green, so it matches everything that we've been doing, and then blue. Now, if you notice, right here we have 18 over 0 for the first coefficient, 18 over 1 for the second, 18 over 2 for the third. So if the third is 18 over 2 and the second is 18 over 1, the 14th is actually going to be 18 over 13, and that's because we start with 0. Then I'm actually going to go to the second thing and say 3b. Now if you notice, 0 here, 0 here, 1 here, 1 here, 2 here, 2 here. So if it's 13 here, it should also be 13 there. And then the last part is this a squared, and a squared goes in that parentheses, and the exponents, 13 and whatever this exponent are, have to add up to 18, and so that's going to be 5. So then when I figure this out, 18 over 13 is 8568. This is a to the 10th, and then this becomes 1594323 4323 b to the 13th. Yikes. And then when I multiply 8568 by this number here, I get this big number of 13,660,159,464, a to the 10th, b to the 13th, and that's the 14th term. So whenever you figure out the nth term, we always do n over this n minus 1. So if it was the 20th term, well, that won't work. If we had the 5th term, it would be 18 over 4. Or the 7th term would be 18 over 6. 6 would also go here, and then the difference would go there. And that kind of goes into the binomial theorem thing. And then the last part of this problem says, show that n over 1 equals n over n minus 1 equals n. And so simply I just write n over 1 equals n factorial over 1 factorial and then n minus 1 factorial. Now to write this out, I know n factorial is n times n minus 1 times n minus 2 dot 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 all the way down to 2 times 1. 1 factorial is just 1, and n minus 1 factorial is n minus 1 times n minus 2 dot 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 all the way down to 2 times 1. Get out the trusty red pen. The n minus 1's cancel, the n minus 2's cancel, the dots cancel, the 2's cancel, the 1's cancel, and what I'm left with is n over 1, which is n. So I've shown that n minus 1 or n over 1 equals n. Second part is the n over n minus 1. And so we're going to do the same thing. We have n factorial on top, and then we have n minus 1 factorial times n minus 1, or 1, no, n minus n minus 1, sorry. n minus n minus 1 factorial. And so what happens with this is when I simplify, I get n factorial on the top. On the bottom, I get this n minus 1 factorial. And then when I distribute this negative, it makes that a negative n and a positive 1. The n's actually cancel, and I'm left with 1 factorial, which is kind of what we had up here. So n factorial is n times n minus 1 times n minus 2 dot 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 to 2 times 1 over n minus 1 n minus 2 dot 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 2 times 1, and then that extra 1. Get out the red pen. N minus 1's, n minus 2's, dots, 2's, and 1's all cancel. You're left with n over 1, which is just n. And there's what we have. You're probably not going to be asked to do something like Part C, but it's always good to work with some of these formulas and understand kind of what's going on. So I hope those two problems help. I hope the videos help, and I hope you're ready to take your test or your group quiz tomorrow. Good luck.